Hi, this is Jeremy, and I'm going to show you in this video how to find normal probabilities using the normal CDF in your calculator for general cases. So this is no longer just Z, now we're talking about an X. So I suppose the first question would be, how would you recognize this from something where you're dealing with Z? Well, if you look at this particular example, it tells you that we have the time per week, and that is normally distributed with a mean of 6.2 and a standard deviation of 0.9. As soon as I see that, I know we're not talking about a Z because the mean for Z is 0, standard deviation is 1. So now we're talking about a normal distribution with a mean of 6.2, standard deviation of 0.9. So my curve looks like this, which in the end is not that different from my other curve, but again, the center is now at 6.2. And when we go out, we're counting by 0.9 when we count by standard deviations. So your calculator has built in the standard normal distribution. And so you have two choices when you come to a problem like this. You can convert to Z. So for example, here in part A, I could find z-score 5. And once I have the z-score of 5, I could then use a table, or I could use normal CDF on the calculator with just z's and be able to find that probability. However, our calculator is more powerful than this. We can actually tell it, hey, we're no longer using Z, we're now talking about this particular normal distribution here. And so I'll show you how that will work by going through this problem. So in part A here, we asked to find the probability the student uses the lab computer. So we randomly select the student. What's the probability that they use the computer less than 5 hours a week? Well, the time that they use a computer is normal. So we got a picture for this. The mean is 6.2. And so less than 5 hours would be below 5. Now 5 is somewhere out here. Remember, standard deviation is 0.9, about 1. So I'm counting out maybe 1 standard deviation or so. And we're looking for this region right there. So working with Z, we learned that this curve goes out forever, and it's true here as well. And so we're going to need a left-hand cutoff and a right-hand cutoff. But the difference is I got to tell it the mean and the standard deviation as well. So this will be a normal CDF minus E99 to 5. But if I just did this, I would get a 1, 100% of the areas between these two, because it thinks I'm talking about a z-score of minus E99 up to 5. And almost everything's within z-score of minus 3 to 3, so of course this would be 100%. What we need to do when we're dealing with something like this is add in the mean followed by the standard deviation. And it always goes in this order, mean, standard deviation. Now, if you're worried that you'll forget to do this sometimes, actually when dealing with Z, you could go ahead and tell it 1 and 0 here, and it'll work just the same. So when I plug this into my calculator, it's just as it was before. Make sure you're using the correct E when you type this in. And I'll end up with 0.0912. So in other words, another thing I could say is about 9% of the students use lab computers less than 5 hours per week, converting this over to a percentage, because probability, area, and percentage are the exact same thing. And so now you can start seeing that this is very similar to dealing with Z, right? For example, here it says find the probability that the student uses a lab computer between 6 and 7 hours. So I would say, well, that's the same thing as area under the normal curve that represents the distribution of time. So here's my 6.2. 6 is just below this, so we're probably about right here. And 7 is a little bit above. So I'm giving myself a little room to draw, but we're looking essentially for this area. Okay, so again, we have our cutoffs this time. Like we did with Z, we have a 6 and a 7. So that's our left and our right-hand cutoff. So this will be normal CDF. 6, 7, but I got to tell it I'm using this normal curve. So then it will be 6.2, 0.9. And so once again, I can type this in the calculator. One shortcut you could do is press second and enter, and it will bring this up again. But you could do this, and then you end up with 4009. Now, as probability statements, we're asked for the probability. You could think of it like this. The first one was probability x less than 5. This might remind you of binomial probabilities, but now x can be any number below 5, not just whole numbers counting down to 0. And this would be probability 6 less than x less than 7. So the last question is probability more than 6.5 hours. So this is greater than 6.5. And so finally I can say, well, that's equivalent to the area to the right of 6.5 under this normal curve. So 6.2 is here. 6.5 isn't that far off. It's not even a full standard deviation. And so we're looking off to the right. And so once again, I can use my normal CDF. The left-hand cutoff this time will be 6.5. But the right-hand cutoff, it goes on forever, so I got to use positive E99. And then I got to tell what curve, so I tell it the mean and the standard deviation. So when I calculate this in the calculator, again, being careful about which E to use and making sure it's positive since we're going to the right. I get 3694. So again, as a percentage, I can think of this as 37% of students use the computer more than 6.5 hours per week in this lab. So again, the only big change is when dealing with X, we have to let the calculator or whatever software you're working with know what the correct mean and what the correct standard deviation is, so it doesn't go thinking you're dealing with Z-scores.